Part 3. Container. A container is a package that collects the files such as source code, libraries, etc., needed to run an application independently on top of a virtualized operating system. Containers are the smallest unit of cloud-native software. Compared to virtual machines, which virtualize hardware, they are smaller and lighter, allowing you to run more applications on the same server environment. Containers can be deployed directly on servers, as well as on top of virtual machines. They are running processes that are managed by the computer's operating system and have constraints on resources and capabilities. A typical container engine is Docker, which supports Linux containers. Docker is an open-source project that automates the operation and deployment of containers and was first released in 2013, leading to the evolution of container technology. Container technology began in 1979 with Unix v7's change root, a command to restrict file access. Container applications have since evolved through open software such as Linux, containers, and Docker to share a single kernel while isolating system resources, such as processes, file systems, and networks. In 2014, the Kubernetes project was launched, and Kubernetes 1.0 was released the following year. Since then, Kubernetes has emerged as a container management standard, and in 2017, Docker started supporting Kubernetes. Since then, global cloud companies have launched a series of Kubernetes management services, and as these services have become more popular, container technology has become more advanced and widespread, and is now a core component of cloud-native applications. Container technology has the following characteristics: fast to run, simple to deploy and manage, and container images can be easily shared and used. Compared to hypervisor virtualization technology, it is lightweight, less burdened by resource waste, and more secure because VMs are isolated. Part 4. DevOps. DevOps is about communication, collaboration, and integration between two roles that are traditionally divided into development and operations. It is a culture and environment where developers and operators collaborate to create, test, and release reliable software in short cycles, with the goal of automating processes. By automating the collaboration process between application development and operations, it speeds up development and improvement. Let's see how DevOps came to be. The waterfall method shown in the figure is a sequential software development process, named for the way development flows continuously downward, like a waterfall. It starts with the software requirements analysis phase, followed by software design, software implementation, software testing, integration, and finally maintenance. With the complexity of connections to systems and the constant changes in technology and requirements, the lack of information sharing between development and operations led to extremely slow turnaround times and unclear accountability. This is when the DevOps software development methodology emerged, which emphasizes communication, collaboration, and integration between the two roles to bridge the gap. DevOps is characterized into four. First, speedy and rapid delivery. By working faster, we adapt to market changes and deliver business results efficiently. By improving the frequency and speed of releases, you can innovate and improve your products faster. Second, secured safety. Ensure the quality of application updates and infrastructure changes. Practices like continuous integration and delivery allow you to test that changes work properly and securely. Third, scalable and secured. Operate and manage infrastructure and development processes at scale. Using automated regulation-level policies, fine-grained controls, and configuration management techniques, security is never compromised. Fourth, strengthen collaboration. Developers and operations work closely together, share responsibilities and workflows to build effective teams. The essential requirements for adopting DevOps. First, Agile. Agile software development is an approach to developing and continuously delivering working software through rapid iteration. It is an adaptive development method that develops software by prototyping, identifying requirements, and applying modifications on the fly at regular intervals based on actual coding, rather than a planning and documentation-based development model. Second, CI/CD, a method of providing app services to customers in shorter cycles through automation of continuous integration and deployment. It improves the quality of software and reduces the time spent on deployment. Part 5. CI/CD. CI/CD is a way to deliver apps to customers in shorter cycles through the automation of continuous integration, service delivery, and deployment. A CI/CD pipeline is a set of steps to take to deliver a new version of software, and it's a way to focus on delivering software more effectively through a DevOps or SRE approach. CI/CD pipelines improve the application development process by introducing monitoring and automation, especially during the integration and testing phases and the delivery and deployment phases. CI stands for continuous integration, which means that new changes to your application code are regularly built and tested and merged into a shared repository. CD stands for continuous delivery or continuous deployment. Continuous delivery means that the changes that developers make to your application are but tested and automatically uploaded to the repository. Continuous deployment means that changes made by developers are automatically released from the repository to the production environment where they are available to customers. Let's talk about the relationship between CI/CD and DevOps. DevOps is a culture and process that aims to improve software development efficiency. CI/CD is an essential way to actualize DevOps. First, DevOps encompasses the entire life cycle of software development, from collaboration to team structure, observation, version control, and more. Second, DevOps can be implemented in many different ways across an organization, but it can't happen without CI/CD. In other words, CI/CD is an integral part of a DevOps culture. Third, a CI/CD pipeline is a tool that actualizes the DevOps lifecycle in a series of specific steps. It is connected to automation. Fourth, a CI/CD pipeline is intrinsically linked to a DevOps culture and a process of frequent, small releases. This concludes Section 3, Cloud Native Application. In Section 4, you'll learn about K-PaaS.